Question 1. We have 2 and 1/7 and 1 and a quarter. Well, here we have 14/7 in 2 whole ones and the other 1/7. And then we have this one here, which is 4 quarters plus another quarter. So that gives us 15/7 plus 5 quarters. And the idea now is to make the denominators the same, so we can do this easily by timesing top and bottom by 4 here and top and bottom by 7 here. So that would give us 60/28 plus 35/28, which is 95/28. If you wanted to write that as a mixed number, that would be the same as 3 whole ones and 11/28, because you can easily see how many 28s go into 95 by just doing the 28 times table in your workings. I haven't shown that here. So either of those answers is fine for part A. Part B, we have 1 and a 5th divided by 3 quarters. So let's change the 1 into 5/5, and we have another 5th here. And don't forget, that's all divided by 3 quarters, which gives us 6/5 divided by 3 quarters. And without going into too much detail, 6/5 divided by 3 quarters is the same as writing 6/5 times 4/3. So look carefully here. 6 divided by 3, that's 2. So we can cancel that down. So we'd have 8, and this would be a 1 here, 8/5. And you've got to write this as a mixed number, and that would be 1 and 3/5. The reason I've cut some of the explanation out is because people have said that sometimes I take too long, so I'm going to just cut this one down a little bit, this paper, and see how that goes. Question 2. In a village, the number of houses and the number of flats, so the houses to flats are in the ratio of 7:4, and the number of flats to the number of bungalows is in the ratio of 8:5. We're told there are 50 bungalows in the village. We've got to work out how many houses there are. Well, if we can get this number here to be 50, that means we'd have to times both sides of the ratio by 10 in this case. So that would give us 80 for flats. But we can make this number 80, can't we, by timesing this number by 20 and then doing the same to this side. So that would give 140 to 80 is the same as 80 to 50. And now that these two are the same, we can now link these two. So we know that the answer is going to be 140 houses. So Renee buys 5 kilograms of sweets to sell. She pays £10 for the sweets. So 5 kilograms, first of all, is 5,000 grams, and £10 is 1000p. So Renee puts all the sweets into bags. She puts 250 grams of sweets into each bag. So first of all, we've got to see how many 250 gram bags we can get altogether. Well, we can divide top and bottom by 10. And then what we can see is 25s into 500. Well, 25s into 50 is 2. So into 500 it's going to be 20 bags altogether. And she sells them for 65p each. So if we do 2 times 65p, that'll be 130 pence. So 20 times 65 is going to be 1,300 pence. And what we can see here now is that 1,300 pence is £13. But she started off with £10. So what's her profit? Her profit is £3, but we want it as a percentage profit. So we've got to look at that £3 and see how it compared to where we started. And we can see quite quickly here that 3/10 as a decimal is 0.3 and as a percentage is 30%. So 30% profit. Question 4. A cycle race across America is 3,069.25 miles in length, and Juan knows his average speed for his previous races is 15.12 miles per hour, and we have to work out how many days Juan will take to complete the race, and we also know that for the next race across America he will cycle for 8 hours per day. So how many days will it take him to complete it? Well, if we look at how far he goes in 8 hours, i.e. in one day, that's 8 times 15.12, and we can do that here. So we've got decimal point, and so we've got 8 5s are 40, and 8 and 4 is 12. So we've got 120.96 miles per day. And so if we want to estimate now, we've got to just look at this sum here as an estimate. So this is how many miles the race is, this is how much is covered per day. And so we can choose simple numbers, and I'm going to choose 3,000 as an estimate for the top number, and for the denominator I'm just going to choose 120, and I can divide by 10 quite easily, and then I can halve this number here to get 150, halve this one to get 6, and then I can halve this one to get 75, and halve this one to get 3, and I can do 3s into 75 in my head, and that would give me 25 days. For the next part, Juan trains for the race. The average speed he can cycle at increases. It's now 16.27 miles per hour. How does this affect your answer to part A? Well, all you need to say is he will complete in a shorter period of time, or it won't take him as long this time to complete the race. So something along those lines. For this question, we're given a solid square base pyramid, and we're given the dimensions, and we've got to draw the front elevation. So imagine we're looking at this part here, and we've got an arrow to show us what we're looking at. Well, we know the base is 6 centimeters. So 1, 2, 3, 4, 5, 6. And the height, well, how can we work that out? Well, if we look carefully, it tells us the height of the pyramid is 4 centimeters. So 1, 2, 3, 4. And all we have to do is join these up here. And that would be the front elevation. So if we want to work out the total surface area of the pyramid, then you can see by the diagram we have the square base. So the base will be 6 by 6, which is 36 centimeter squares. But it's a bit more tricky for the triangular faces. So it's not the height being 4 in this case, because it's going to be the surface area, so it's going to have a slant height. So how do we work that out? Well, looking carefully at the shape, we can see here that if this height here is 4, which is given, and we know here that from here to here has to be the same as from here to here, which is 3, this being a right angle. I'll do that in a different colour so you can see. you can see then that the slant height here is going to be 5, because by Pythagoras we've got a 3 squared plus 4 squared would give 5 squared, and you can work that out quite simply yourself. So in this case we have 4 of those triangles, so we have the triangles here, and that's going to be 4 lots of base, which is 6, times height, the slant height, which we've worked out, which is 5, over 2, because the area of the triangle is base times height, all divided by 2. So we can cancel that down, and that gives us 4 times 3 is 12, times 5 is 60 centimetre squares, and then we just add these two together, and that gives us a total of 96 centimetre squares. Question 6. I think this is the hardest question on this paper. Well, it is for me anyway. I don't know if it is for you. We're starting at 6, 7 for A, and we're ending at B, 38, 36. And it says the pattern is made from 4 identical squares, same side, same length for each side, and the sides of the squares are parallel to the axes. So the first thing I looked at was how to compare the x parts of the coordinate, and from 6 to 38 is a difference of 32, so I know that this distance is 32, and then I looked at the y's, and the difference between 36 and 7 is 29, so I knew that distance there was 29. And then I got stuck for a little bit, but then I thought, well, hold on, these are 8 then, because to get 32, we've got 1, 2, 3, 4 sides to get 32, and they're all the same because they're identical squares, so they're all at 8. And then the penny drop, that of course, these are 8 as well, including this one. However, to get from 7, which is a y value, to 36 is a difference of 29, and you definitely have 1 8, another one, and another one, so that's 24, which only leaves 5 left, and that must be this height here, because it's some height gained on the y, which means that this value here is 3, and I can't really make that much clearer than I have there. So what's the coordinate of C? Well, we know we've got to go 8, 16 along, but we started at 6, so we've got 16 to add to 6, which gives us 22 along so far. And how far up? Well, we've got to go 8, then we've got another 5 here, and again I find this quite difficult, because if this part was 3, then this is 5, because this makes 8 as well, so I just find that difficult. So this is 5, and so we had to go 8 and another 5, which is 13, but we started at 7, so 7 and 13 is 20. So the coordinates of C are 22, 20. Question 7. It says that shape T is reflected in the line x equals -1. Well, x is -1 is this mirror line here. And if we reflect that, it's 2 units away, so it starts here. And then as this is 2 units, then this has got to be 2 units as well, and then we just draw the triangle and label it R, and it wouldn't hurt us to label this x equals -1, and then R is reflected in the line y equals -2, so y is -2 is this line here. I'm doing it dotted, you probably should do a solid line in the exam. So y equals -2, and so that's 1, 2, 3 units away, so it's going to be 3 units this way. And again, we just draw a triangle and label it S. It then says, describe the single transformation, so a single transformation, that will map shape T to shape S. So if you think about it, it's a single transformation and it's not going to be a reflection, is it? So I think it's going to be a rotation, so I'm just going to check out something and see whether it works. Well, what I've looked at is, I've looked at corresponding points. So for example, if I look at this point here, that was reflected to go to here and then ended up here. So if I carefully draw a line, you can use your ruler in the exam. So if I draw a line starting from here and ending here, then that's my first step. The second step is I look at the next corresponding point, and if we just choose one, I can say this one here is reflected to here and then here. So I'll do the same process again. Obviously it takes me a little bit longer than what it would take you, so let's join that up. Now can you see where those lines cross? They cross at the coordinate -1, -2, and if I just complete the last point, which should be quite easy to match up, to here, that already goes through the one I've already done, and I don't think it's exactly the same, but it still goes through the point -1, -2, all the same, and that would be the place at where the either rotation happened, but I can see in this case this would be a centre of enlargement also. So I think there's two different answers here. So one potential answer would be enlargement. Let's get the pen working here properly. So there'd be an enlargement by scale factor. In this case, the area is preserved, but it's inverted, so it'd be the scale factor of -1 about the centre, and we've got that already, -1, -2. But I've also got a hunch there's some kind of rotation going on. Now that's going to be really hard to show on here, but I'll give it a go. Well, this is the best I can do right now, so it's made the words all rotate as well. But you can see, if you watch this a couple of times through, that we're starting at T now, and we're ending up at S just now, and we've gone through 180 degrees. So I would personally say that we've also got a rotation 180 degrees, let's wait for the words to go by, 180 degrees clockwise, around the same centre as we had before, around centre -1, -2. So that would also get you the mark. So I hope you can follow my diagram. It's just really hard to do that on the software that I'm using. Question 8. The perimeter of a right-angled triangle is 72 centimetres and the lengths of its sides are in the ratio 3 to 4 to 5. So if we look at this all together, we have 3 and 4 is 7 and 5, that's 12 parts. Well, we want 72 if you think about it, because that's the total perimeter. So these lengths here would make 12. To make that 72 and keep it in proportion, we'd have to multiply the 12 by 6. So we have to do the same to each of these. And 5 times 6 is 30. 4 times 6 is 24. And then the 3 times 6 is 18. So we can see now that we've got our 72 here for the total perimeter. And we can look at our right-angled triangle, remembering the hypotenuse has to be the largest. And we can call this one 18 and this one 24. We want to work out the area, so that's going to be base times the height, perpendicular height that is, halved. So to make that easier for us, we can say that's just 2's into 18 is 9. And so the answer is 9 times 24. And that gives us 216 centimetre squares. Question 9. 36 to the power of half is the same as writing the square root of 36, which is just 6. Anything to the power of 0 is 1, so we have 1 here. And 27 to the minus 2/3, well, that's a little bit more complicated. That will be the same as 1 over 27 to the 2/3, because that's what the negative power does. It takes the base and it finds the reciprocal, i.e. 1 over it. And the denominator, 27 to the 2/3, well, that can be written as 27 to the power of third all to the power 2. Because if we have the rule a to the power b to the power c, that's a to the b times c, or a to the c times b. So it's easier in this case to do 27 to the power third, or the cube root of 27 first, and then square it, rather than doing 27 squared first and then cube rooting. So you want to get it in this order, not the other way. So if you know 27 squared, then that's fine, it's 729. But if you don't, and you're worried about making mistakes, just make it easy for yourself. So we're going to have 1 over, 27 to the power third is the cube root of 27, which is 3, and then we're going to square that, and that gives us the answer 1/9. Question 10. The table gives some information about the heights of 80 girls. We've got the least height is 133 centimetres, so that's 133. So we can do our least part of our box plot here. We'll look at the greatest next as 170. Then our lower quartile is at 145. Our upper quartile is 157. And our median is at 151. Obviously you'll use a ruler in the exam. And there's our box plot. It then says work out an estimate for the number of these girls with a height between 133 and 157. Well, 133 is the least, and 157 in this case is the upper quartile. So going from the beginning of the data to 3/4 of the data, which is the upper quartile, because don't forget we have the first quarter here, the median is the second quarter, or the halfway mark, and this is the 3/4 mark. So as there are 80 girls, it's just going to be 80 times 3/4, or 3/4 of 80. And 4's into 80 is 20, so we've just got 60 here, so 60 girls. Question 11. A and B are points on a circle centre O. BC is a tangent to the circle. AOC is a straight line, and angle ABO is x. So that's the first thing we've got to look at here, is that ABO is x. So we've looked at that, and we've put that in our diagram. It says find the size of angle ACB. Well, ACB is going to be this angle here, and that's what we want to end up with. Give your answer in its simplest form. And we want it in terms of x. So the first thing we can look at, I'm not going to write all the explanations down here, you'll have to do that properly in the exam, but I'll briefly go over it. In this case, we have a radius here and a radius here. So we know that OA and OB are radii. So we know that triangle OAB is isosceles. So we can say that this angle is therefore x, because base angles of an isosceles triangle are the same. Well, what does that leave this angle to be? Well, the angles in a triangle add up to 180, which you'll have to state, and therefore this top angle here, AOB, must be 180, because we need to have the angles adding up to 180, but because we have an x here and an x here, it's got to be 180 minus x, because if we added 180 minus x to these two base angles, which are x plus x, then we're just going to be left with 180. So that's quite difficult. So we can simplify that as 180 minus 2x. Now, the next thing to think about is that the angle between a radius and a tangent, because don't forget it said BC was a tangent, well, this is 90 degrees. So we can now find this angle here, because in the triangle ABC, here, ABC, we already have x for this angle. We have 90 plus x for that angle, and we know that the angles in a triangle, again, and you'd have to write this down, angles in a triangle are 180 degrees. What do you think angle BCA or ACB has to be in this case? Well, if we already have 90 plus 2x in terms of angles already, then all we need is 90 more and then minus 2x, don't we? Because if we added those together, what would we be left with? Well, 90 and 90 is 180, which is what we want. Angles in a triangle are 180. And then the plus 2x is cancelled out by the minus 2x. So the angle here in question that we want is 90 minus 2x degrees. Now don't forget, like I said before, I've not written all the reasons out because it would just mean the question would take a lot longer to explain. Question 12. Prove that the square of an odd number is always one more than a multiple of 4. Well, let's say we choose 2n plus, let's say 1 as our odd number. Then the next odd number would be 2n plus 3, 2n plus 5, and so on. And the one before you could write as 2n minus 1. So any of these would work, but I think the easiest one to work with is 2n plus 1. So that's going to be our odd number. We're now going to square it. So don't forget how to square a bracket. You don't just square the first and the last. So 2n all squared is 4n squared. 1 squared is 1. You also have these parts, 2n by 1, which gives 2n, and 1 by 2n, which would give 2n. So we'd have 4n squared plus, well, 2n, and 2n is 4n, and then finally the 1. Well, how is that 1 more than a multiple of 4? Well, if we look carefully here, 4 here is a common factor, so we can take that out, and we've just got n squared plus n, add 1. Well, now looking here, in the bracket here, n squared plus n is just a number, but the most important thing is we're timesing that number by 4, which makes it a multiple of 4. And then we're adding 1, so therefore we've got 1 more than a multiple of 4. Question 13, we have an expression root 5 multiplied by, all in brackets, root 8 plus root 18, and we've got to write that in the form a number multiplied by root 10, or a multiple of root 10. So let's look inside the bracket first. Root 8 is root 4 times root 2, and root 18 is root 9 times root 2. Now you've got to ask yourself, why have I chosen 4 and 9 here? Well, 4 is pretty much what it has to be, but I could have chosen 6 and 3, but the reason is, if I choose square numbers, so 1, 4, 9, 16, 25 and so on, if I want to square root these, then they're easily deconstructed. So the square root of 1, square root of 4, square root of 9 and so on. Whereas if I put a 6 here, the square root of 6 doesn't really simplify to anything, whereas the square root of 9 does. So we're left with root 5 lots of 2 root 2 plus square root of 9 is 3 lots of root 2. And then inside the bracket, that simplifies nicely to be 2 lots of root 2, and 3 more lots will give us 5 lots of root 2. Now, we're nearly there, because root 5 times root 2 is just what we wanted. And we have 5 left. And don't forget, when I write root 5, lots of 5 times root 2, that's exactly the same as writing root 5 multiplied by 5 multiplied by root 2, and multiplication can be done in any order. So that's how I got the root 10, and then I've just got 5 lots of root 10, and that would be my answer. Question 14. It says that y is inversely proportional to d squared, and it gives us some information after that, but the interesting thing to say first is that that means that y is equal to k over d squared for some k, and we're given this information here to find the value of k. So when d is 10, we've got 10 squared here, we're given y is 4, we can rearrange, so we're left with 4 times 10 squared, which is 100, and that makes k 400. So all I have to write is y is 400 over d squared, and I'll put a box around that because that's the first part of the question. The second part is just a repeat. It's the same kind of process. So d is directly proportional to x squared, means that for some k, d is equal to k x squared. Now it's not the same value of k as in here, so I think it might be better for me to probably choose a capital K to distinguish between them. And again we're given some information. So when x is 2, d is 24. So we're just left with 24 equals 4k. and then k is going to be divide both sides by 4, 6 in this case. So we come back up to here and we can write d is equal to 6x squared, and we'll put a box around that. So if we look carefully here, we want y in terms of x. So we really want to get rid of the d, so eliminate the d. So the best thing I think to do here would be to square both sides of this, and would have d squared equals 6x squared all squared. And be careful here, we'd have d squared is 6x squared times 6x squared will be 36x to the power 4. And from here, if we rearrange for d squared, we'd times both sides by d squared, and then we'd divide both sides by y. And now we've got something linking d squared to both. So what we can say from this is that 36x to the power 4 must be equal to 400 over y. Now, from this, we can easily find y in terms of x, so make y the subject. We can times both sides by y, and then we can divide both sides by 36x to the power 4. We can then cancel because we have 400 on top and 36 on the bottom, they're both even. So that would be 200 over 18, and I can cancel again to give 100 and then 9 here. So we'd have finished off with y equals 100 over 9x to the power 4. And don't forget, that's 9 times x to the power 4. Question 15. We need to factorise a squared minus b squared. Well, that's a difference of two squares. And that's a plus b multiplied by a minus b. Why is that the case? Well, if we look at a grid here and multiply these out, we get our a squared. Here we have ab, here we have minus ab, and in this position here we have minus b times b, which is minus b squared. The minus ab cancels with the ab, and we're left with a squared minus b squared. So that's why we can write it as a plus b times a minus b. And if we look carefully here, this part b is just using part a. So if we just call this our a and this part the b, so you can almost think of it like this, then if we abide by a plus b times a minus b, or a minus b times a plus b, it doesn't matter which way round you write it, we will have x squared plus 4 plus x squared minus 2 in the first bracket, this being the a and this being the b in here, and then multiplied by x squared plus 4 minus, and be very careful, a small bracket here, x squared minus 2, and then end it with the large bracket. And what we've got here is then our a again, and then we're taking away the b here. And if we just look at simplifying here, x squared and x squared, that's 2x squared, 4 take away 2 is just 2. And in this bracket, x squared take away x squared is 0, and 4 take away a negative 2 is 4 add 2, which is 6. Here we can take 2 out as a factor, and the 2 times the 6 is 12, and in the bracket we have x squared plus 1 for 3 marks. Question 16. There are only red, blue and purple counters in a bag. So red, blue and purple. It says the ratio of the number of red counters to the number of blue counters is 3 to 17. And at this moment we'll call x for the purple because we don't know that, because it doesn't tell us the ratio for purple. But it does say that Sam takes at random a counter from the bag and the probability that the counter is purple is 0.2, which is 1/5. So what I would argue is that in 1/5 of the cases, well, what would the probability by the ratios be? Because it's all got to be in proportion. We'd have 3 and 17 is 20 plus x. So there'd be 20 plus x parts here. And how many of them were purple? Well, we called it x. So we know the proportion of x out of 20 plus x must be in the same proportion as 1 out of 5, or 1/5. So we can just rearrange that. So what I would do is, I'm just going to write this out here so we've got plenty of room. You could find the reciprocal of both sides, but I think what I'll do here is I'll times both sides by 5. And then both sides by 20 plus x. I'll just put a bracket around it so you can see what I'm doing. So I'm timesing this side by 20 plus x. If I times the right hand side by it, then the denominator disappears and becomes 1 unit. And then I can take x from both sides and then divide both sides by 4. So that gives me the missing link in the ratio here of 5. And then work out the probability that Sam takes a red counter. Well, that'll be 3 parts out of a total of 25 now. So that would be fine as an answer. But if you want to do it out of 100 by timesing top and bottom by 4, you've got 12 hundredths, or 0.12. And I'll probably put that because the question was working as a decimal here. So the probability would be 0.12. Question 17. We want to simplify fully this expression as a fraction. So let's start with the denominator, because that usually gives us a clue as to what we need on the numerator. And if we look at the denominator here, we can make it 2x as a common factor, and then we have x minus 3 here. And this x minus 3 is a good clue as to what we need to make happen on the numerator. So it's not always the case, but let's just go for it and see. So if we create an x minus 3 here, will we indeed have something in this bracket that will give the numerator 3x squared minus 8x minus 3? Well, this would have to be a positive 1, because only a positive 1 times a negative 3 will give a negative 3 here. And we have an x here, so we're going to need a 3x here. And if we do a quick little grid here, if we put x minus 3 at the top and 3x plus 1 down the side, multiply it out, we have 3x squared minus 9x plus x is minus 8x minus 3. So we can now cancel this one here with this one here under multiplication, because this is being timesed here. So x minus 3 divided by x minus 3 is just 1, and that's why we can cancel them. And we're just left with 3x plus 1 divided by 2x. And when I say 3x plus 1 divided by 2x, I mean 3x plus 1 all divided by 2x. Question 18. you can see the graph of y equals sine x between negative 180 and 180 degrees. And on the grid, you're supposed to sketch the graph of y equals sine x minus 2 for the same interval. Well, all that is doing here is translating the graph downwards by 2 units in the y direction. So what we have here is one point here has gone down by 2, and that's like having 0 minus 2. So that's 1 point. This one here is 91, so it goes down to stays at 90 but goes down to minus 1. I can do that a bit better. So that's 90 minus 1. And then this one would be 180 minus 2. And this one would be negative 90. Well, that's already minus 1, so that would be on minus 3. So that's negative 90 minus 3. And then lastly, 180 minus 2. Negative 180 minus 2, rather. So there are all the points. So all I've got to do is smoothly join those up. So we'll start with this side first. So I'll just move this around a little bit. So that's that one done. And then I'm just going to turn my drawing surface around so it's easier to get the nice curve on this one. And that would be my graph between those between negative 180 and 180. And I might just write down here that the graph has been translated by negative 2 in the y direction. Something like that. Okay, because that backs up your diagram. Question 19. P has the coordinate 3, 4, and Q has the coordinate AB. So let's just say this is the line where P and Q lie on. It's saying that a line perpendicular to PQ, i.e. one that is at right angles to it, is given by the equation 3x plus 2y equals 7. Well, if we rearrange that, that means 2y is equal to minus 3x plus 7. And we can find the gradient by getting it in the form y equals mx plus c. We can divide everything by 2. So we can see the gradient here is minus 3 over 2. So that means that the gradient of the line PQ, which is at right angles to 3x plus 2y equals 7, well, I'll call that n for normal because it's at right angles to it, must be the negative reciprocal, so it must be 2/3. Now basically, if you have a gradient and you times it by the normal, you're always going to get -1, and you can look on other videos on YouTube or Google to see why that is the case. So we know the gradient here is 2/3, but if P was 3, 4 and Q was AB, then how do we find the gradient? Because we know what it is, but how do we find it using the coordinates? Well, we do the difference in the y values, so we can do the b minus 4, that's the difference in the y. You could do 4 minus b, that's absolutely fine. But as we've started with b minus 4, the difference in the y, we've got to do that divided by the difference in the x, which is a minus 3. And that would be the gradient, which is 2/3. So just out of interest, you could have done it the other way around, and you'd get the same result. Okay, but we'll stick with this one now. So what we can do is we can say Well, we want to find an expression for b in terms of a, so we've got to make b the subject, so we can times both sides by a minus 3. And then we can add 4. And we can probably rearrange that a little further. Or should I say simplify that a little bit more. And what we could do is we could just say b is equal to 2/3 of a minus 3 lots of 2/3 by just multiplying this out here. And then if we added the 4, what we'd end up with is probably something a little better and would gain all the marks, because we'd have b equals something to do with a, and then we'd just have a constant at the end. So we'll go with that and see what that gives. So we'd have b equals 2/3 a minus, well, these 3/3 cancel to one whole one. That just leaves 2 left. Add 4. Well, the answer is now easy to see. We've got 2/3 a minus 2 add 4 is plus 2. That would gain all the marks, but I think you could, if you wanted, just carry on a little more and say something along the lines, if we took 2a over 3 plus 2, we could times top and bottom here by 3, this being 1 of course, 2 whole ones, and that would give us 2a plus 6 all over 3, and then what you could do is factor a 2 out of the top to give this as b. So sometimes if you end up with something you're not sure if it's correct, and you went outside the exam and said, oh, you said to your friend, well, I got 2/3 a over 3 plus 2, and they said, well, I didn't get that. You probably still could have both got the answer correct, just that you got different forms, so don't worry about it too much. Question 20. It says that n is an integer such that 3n plus 2 is less than or equal to 14, and 6n over n squared plus 5 is also greater than 1. So when we've got and here, we've got to see some overlap between them both, and then hopefully that will allow us to find the possible values of n. So let's do this one first. So if we take 2 from both sides, we get 3n is less than or equal to 12. If we divide both sides by 3, that's not going to change the inequality sign, because we're not dividing by a negative or timesing by a negative. So that would give us n is less than or equal to 4. If we look at this one here, we can times both sides by n squared plus 5. And the reason that the inequality sign won't change is because n squared is going to always be positive, and if we add 5, that's also positive. So we're just timesing both sides by a positive number, so that's not going to change the inequality sign. And if we take 6n from both sides, and rewrite, if 0 is greater than the right-hand side, that means the right-hand side has to be less than it. We can factorize this. And what we now have is a situation where if we look on a number line, and I'll draw one here, if we mark on the points 4, 5, because that would be solving the bracket, equal to 0, so 5 would be an important value here. If we solve the bracket equal to 0, if we did, we'd have n is 1. So let's try and keep this to scale. So if we look at this situation here, we have a quadratic which is going to be less than 0. Now, a nice way of looking at this question is to say to yourself, well, a quadratic leading with a positive term in n squared is going to have this shape. So if its critical values were here and here, then we could imagine it going through and looking something like this. Now, where is that less than 0? Well, it's between the 1 and the 5. That's where it's less than 0, i.e. underground, so to speak. Now, I didn't do a full circle, I did a hollow circle here because we didn't have equal to, we just had less than. Now if we look at this part, we have a situation where n has to be less than or equal to 4. So if we had a number line underneath, we can be equal to 4 and we can be any other integer value, 3 and 2, but we cannot be 1 because it's not satisfied by this side. Okay, so it has to satisfy both conditions, and therefore the only ones that are satisfied in both conditions are the value of 2, 3 and 4 as integer values. So my answer would be 2, 3 and 4.